Hey everybody, I'm Robbie from TDP, and in this video we're going to show you some repairs we're doing to an RB25 cylinder head, along with some upgrades, and then how it's built onto a road car bottom end with a set of forged pistons. So what you see now is the head being set up on a jig on our 5-axis milling machine to have some exhaust stud holes repaired because they were overzealously drilled out by somebody with the wrong equipment and the wrong skill set. And they did a lot of damage to the head, and they over drilled the holes into the oil and the water galleries. So we set the machine up on we set the head up on our machine, and from there we use all the machine's capabilities like this Renishaw spindle probe to gain an accurate position of the Z axis and the X and Y point of one of the good holes, and then we use the machine again to bore out the damaged threads to a much bigger size, or because often people get them crooked, and what happens then is we're able to put an insert in, but we've just, as you just see here, cutter got broken because we drilled down into the bottom of the hole to find that there was an easy out in it, which broke the cutter. So after a quick cutter change, we resume and get that hole repaired. This head was one of the worst we've done in a long time. There was 8 holes, I think, damaged. We even had to weld this one that we're on now onto the head face because it was been drilling out through the head face, so it was really bad. So once the holes are all drilled for our special homemade inserts, we tap them with this big tap, which is way bigger in size than the original head stud, and the idea is to be able to put a nice bit of new material like this billet aluminium in, and we put some sealer and Loctite on it, and then we basically tighten it in. And what happens then is it's made here on our lathe, and we make it longer than we need, but we also waste it away a bit, so then when we tighten it into the head tightly and give it a good turn, it'll actually ring off, it'll break and leave the studs in the head. And what happens then is we can machine off the top of the stud, and basically once that's done, we have a brand new piece of high quality aluminium in the head where the head stud hole was, which we can then re-drill and re-tap to the original. Now where possible, we obviously try and make sure that these don't leak any fluids out around them, so they are sealed with proper sealer and also Loctites with a sealer type Loctite, not particularly just for holding the thread in, but to stop them leaking. So there they are now, they're installed in the face of the head, and they stick up proud because they all go in a certain depth and then they stop. And what happens next is we machine the top off them before we drill them and tap them, and here we are, machine will just drill the top off them now. This process is all highly speeded up. This takes a bit longer than it looks here because we obviously take great care. These heads are getting rare now. Now we actually just take 0.1 or 0.2 of a mil off this whole face. So we have a brand new flat face for the gasket, and it's nice that it's all checked and machined to the same Z level, and gives a really good job when it's finished with the inserts in, as you'll see now when the camera moves over. So now we have all our brand new inserts and the original ones that are okay, ready to go, and at least it'll hold an exhaust gasket on. So we move on to the assembly of the head. So after the head's fully machined and cleaned, obviously it has to be assembled, and this is something that people can get wrong as well. And in the assembly here, we just make sure that the washers that are underneath the valve seats are put in properly, because we've seen these either missing or put in and then sitting crookedly and stuff like that, causing the valve springs to bind and all sorts of things. So once they're in, then we just put more lube in. You can't beat enough assembly lube on these, because you sometimes don't know how long the engine will be until the customer gets to start it, so we always try and make sure everything's properly lubed up. So then the springs go in. If you're building an RB25 head and you're not sure and you've stripped one and you didn't label everything like you should, just a hint, the shorter valve spring goes on the inlet side. Now basically we're fitting the valve retainers and the cotters, and we have made our own valve assembly bench. After many years of using lots of different type assembly benches, we decided to build our own. So you'll see now in a minute how easy it is once you have all of the head just sitting here prepped, how easy it is to pop them in. So get them all in. Again, plenty of assembly lube on everything. It's a good job, especially with the cotters, because it makes them sticky, and if you manage to drop one or something, the cotter generally doesn't go too far instead of going flying if they're dry. So good idea. So here's our head assembly bench. So we have a piece of material that goes in underneath in the combustion chamber. It's the same shape as the valves, and it supports the valves absolutely perfectly. And then we have our own hinged lever mechanism, fully adjustable, that comes down off the bench and allows us to just clip the cotters in with this spring-loaded tool in no time at all. We love it. It's brilliant. It's really good for stripping and building heads rather than a valve spring assembly tool. So I don't like them at all, and they're really annoying. This is much faster. So we clip it together, keeping moving along the insert to make sure that we are not bending any valves. And basically there's the head assembled. So already I'm fast. I'm on to putting the oil squirters into the block, and they're put in and torqued, obviously, after everything is properly cleaned, measured. This is the final build now. This isn't the assembly build, which we haven't shown you, where we basically dry build it to check the clearances. So this is the full build. So everything has been really well cleaned now. Cleaned inside and out, the galleries and everything, flushed out and reamed and gone through with brushes and all. And then we basically put in the cleaned crank. The bearings have already been thickness checked for tolerancing, so they can go straight in. And we've plenty of assembly lube on everything. Always make sure the mating faces are free of lube and dust. Then plenty of ARP ultra lube for the heads of the main bolts. Pop in the main bolts, spin them down, and we would give them a nice torque then. So if you're not sure, main bolts in an RB are torqued to about 38 foot-pounds. And then check the crank spins freely. That's the main thing. So then pistons, this engine's just getting a set of forged pistons because the block was oval and bit of scoring on it, and the original pistons didn't look so good. So we check the ring gaps, very important, check the ring gaps. So you can have a slightly bigger ring gap than normal, that's okay, but if you have too tight a ring gap and the engine gets hot, what happens is through expansion the ring expands so much that the ring basically becomes solid. Here we actually are just finishing the conrods. They've already been closed, honed and measured. Actually, this is just a really fine stone to give a really good surface finish. And why that's important is the surface finish allows the bearing to dissipate the heat into the conrod, and that stops the oil overheating locally in the bearing area. And again, it's just another thing that stops engine failure, premature failure. So here we are assembling the pistons, putting the gudgeon pins, the clips in. Now your fingers, if you're not used to this, get sore pretty quick putting the clips in. I've been doing it for years by hand, so I'm kind of used to it now, but after a couple engine builds in a row in quick succession, the ends of my thumbs get a bit sore. Now basically bearings into the conrods, bearings already checked, so basically conrod, they can be fully assembled. They just go back in. Try and keep everything in absolute order here, and they go in. Then we use tapered piston installing tool because it's the best way of not damaging the rings, and it's also really good at making sure the ring gaps end up staying where you want them in the bores. So plenty of lube again, and conrod caps on, and just snug them together for now. We'll get them all in before we torque them. And again, just can't beat this tool for being able to put the pistons in quickly, easily and safely. I've never broken a ring with these type tools. We make them in-house ourselves out of a high quality Delrin acetyl type material. Really nice, and we can make them any size we want in our in-house lathe. So yeah, it's the job. So, this engine's only getting a set of standard conrods. They're good for quite a bit of power, probably not above 500, but up to 500 they're quite adequate. And now we're on to torque. So Standard Conrod bolts require a small snugging torque of 16 Newton meters first, and you just do that. And then once you have that done, then you give them a 60-degree angle torque. And that's very important to do that properly. Now we checked the deck height because this block had been machined loads, and we found that the pistons protruded too much through the top of the deck, and as a result of that we need to increase the clearance between the flat area on the piston and the cylinder head. So in other words, the quench area, or the squish area some people call it. So basically the head goes back on the machine, and we make sure that it's all aligned properly. We use our spindle probe. Basically what we're going to do is, because we've only got a thin head gasket supplied with this engine build, we're going to bore the bore diameter of the head gasket slightly further up into the cylinder head by the amount we want for our squish, and that will mean that if we have situations where Conrod is stretching at high RPM, that we won't have the squish coming down to too tight a measurement, and the piston possibly touching the head, which would be pretty bad. So like I think we only took about 0.5 or 0.6 of a millimeter down on this. Probably wouldn't have been necessary. A lot of people wouldn't do it, and we've already got a chambered cylinder head, so it probably wouldn't touch. But we don't do probablys here. We make sure everything's done properly, because we have a golden rule number that we use depending on the Conrod involved. So make sure the top of the block is clean, devoid of all oils. Cosworth head gasket, the stopper type, we find very, very good, and on with the pre-built head. ARP head studs in this build, just spin them in, really low torque. The little gun we use puts them in at about 10 pounds-feet, that's all. And then plenty of ARP Ultra Lube on the washer and the nut, and on with the nuts. And once the nuts are on, obviously then we torque the head in 4 or 5 stages down to the maximum torque. We use 77 foot-pounds, as we found to be very, very good on RB25s. Never had a problem with it, so we do that. Takes a while. As you get to the higher torques, you start having more things. Now actually onto the nose of the crank. This crank was fitted with a sleeve. We don't just rely on the grub screws for the sleeve, we actually TIG weld on the sleeve as well. So you'll see the front of the crankshaft has little marks where there are little holes in the weld, but that doesn't matter at all. It's done pretty well, and we have done it over many years like that. So on with the gasket, on with the OEM Nissan oil pump, and once that's on, then I suppose we can put the water pump on. Again, just make sure everything's nice and clean, and get your water pump on, and we torque absolutely everything while we're doing it to make sure that there's no issues with things not sitting square or anything. So now just a small bit of Loctite for the studs that come for the water pump, wipe the excess off. Bit of Loctite for the idler pulley as well, pretty important, and torque it to spec. We torque it to I think it's 80 Newton meters. Then on with the tensioner, and then on with the rear main seal. So we're trying to get the whole engine together now. We want to allow things like sealer to go off in places while we're working on other things, so we will swap from one end of the engine to the other as needed. So now what we're doing is actually going back over all the bolts that were previously torqued. We're not aiming to torque them again, we're just basically going over them with our digital wrench to check if there has been any change in the torque on them. In other words, have any of them slackened through stretch? You know, if you get a bolt that's fatigued and you've torqued it to its stretch range, sometimes it can basically continue to stretch more than you'd like, and you will feel it go a tiny bit soft. So it's just a precaution, something we've done for years. We're not actually putting any more torque on them, we're just checking that they don't move. Now we're just putting some more assembly lube into the oil pump, because the last thing you want to do is have an air-locked oil pump when you go to get the oil pressure up. So that's just one of the ways of priming the pump. That's just to prime that part of the pump. Now head back up, and the hydraulic buckets cleaned up and checked, all in. So some of these tasks are monotonous, there's 24 of these. Then again, more lube, can't have enough of it. We like this Lucas heavy engine oil stabilizer as an assembly lube. We find it works very, very well. And we've used it for many, many years. We've had to strip down a few engines that we've supplied people, and they've had problems with them when trying to start through something going wrong, and they were scared to run the engine on. So we've pulled them apart to find that the assembly lube has left them looking like there was plenty of oil in there all along. So we stand by it now. We've used some of the other special lubes that you can get, and they are fabulous too, but with the quantities we use, we can't basically you can't beat the Lucas. And I'd advise anybody who's assembling an engine at home, if they're not sure what to use, this is better than engine oil. It doesn't run away, it's really, really sticky, and it'll not run off if the engine's not started for a while. Now you need to be careful when putting the cams in. Yes, I'm using a power tool, I've done it hundreds of times, but I'm also, in the video you can't really see because it's sped up, but I'm not letting the cam or the bolts turn by more than basically one turn each time. So the trick is to just guide the cam down in a nice and level way. So on with the front cover, on with the cam pulleys. Torque the bolts, very important to torque these bolts, especially this one on the VVT sprocket. 85 Newton meters from what I remember. In with the little bolts, and once that's done, you can set up the positions of the pulleys and on with the cam belt. Once the cam belt's on, we tension it. A lot of people over tension the cam belts in RBs. Don't do that. Don't do that. Just let the spring do its work. And then I think it's ready for the sum. And that's nearly about it now, because don't think we've any more parts for this engine. Customer's going to do the rest. Then they're going to bring it back to us for initial startup, where we'll make sure it gets up oil pressure in the minimum time, cranking for the bearings, and then we'll run it in and dyno it. And it should be a nice engine, should make some nice power. It's got all the right bits, all the bits that needed attention were done, so should be very reliable for the next good long time. We've lots of these engines out there running for 5-10 years now with this sort of technology in them, and they're getting huge mileage on them, and they always run fine.